Welcome to the Power System Architecture online classes. In the last class, we have discussed what is power system, what is the structure of power system, what is the basic definition of power system architecture, and finally, what is the need of power system architecture. So here, the need of a power system architecture is mainly to obtain the better technical performance from the power system operation. So here in the better technical performance means we are discuss the energy conversion efficiency in the generating stations, the power transmission system efficiency, and distribution system efficiency with respect to the power losses, and the low cost operation of a system design. One more thing is that in a need of a power system architecture, in the technical performance, two more important points are continuity of power supply and the quality of power supply. So here what is mean by continuity of power supply? So here, for example, the power can be generated in the generating station and which can be transmitted with the help of transmission system and finally distributed to the various types of consumers in the distribution system. So totally here the power supply means the conveying of power or delivering of power from generating station to the consumer terminals. Delivering or conveying of power from generating station to the consumer terminals is called power supply. Every consumer always wants continuity of power supply. That is one of the main objective of the power system. Why? Because of if any discontinuities in the power supply, what happens? Means you are already faced in our household applications. What happens due to power cuts? There is no lightning. What happens? Your entertainment channels are closed. Your cooking is somewhat delayed. If that problem which goes to the commercial application, so many are problems in the commercial application like restaurants, theaters, and industries. If the production can be delayed with the discontinuity of power supply due to delaying of production, there is a large amount of loss in their profit, in their economy. That's why continuity of power supply is very much essential for power system. At the same time, quality of a power supply. Quality of a power supply means, for example, if your domestic application is a 230 volts a single phase, the voltage rating is 230 volts and a single phase system. Due to any reasons, the voltage may be raised beyond 230 volts. What happens? Insulation failure may occur. Finally, what happens? Insulation failure means short circuit takes place between any two wires. If there is a short circuit, all the wires are burned out, your equipments are burned out. In case of industries, industrial equipments are damaged. So due to any variations in the voltage and currents frequency, the actual magnitudes are deviated due to any disturbances. What happens finally? The equipments are damaged. That's why always the power system maintains the quality of power supply. That means these two, continuity of power supply, quality of power supply, are also very much essential and better technical performance of the power system. That's why the power system architecture helps to maintain the continuity of power supply as well as quality of the power supply. So this is about the need, necessity, requirement, advantage of power system architecture. And now the thing is, why we can generate electrical energy? What is the necessity to generate electrical energy? Means for the utilization purpose. Why we can use electrical energy? In our domestic application, directly we can observe what happen in our domestic application in our houses. If there is a switch on, lights are glowing, illuminated, TVs are running, refrigerators, rice cookers, heaters, mixers, grinders, all are working on the electrical power supply. But actually, if you can observe, for the electrical bulbs, they can give in light energy. Heaters are given heat energy. And the motors are given mechanical energy to lift the water from well. Then what is the necessity of electrical energy here? Here, the electrical energy can be converted into light energy, heat energy, mechanical energy. Why we can take those energies directly? Why don't we can consume all those light energies, heat energy, mechanical energy directly? Means every energy never exists directly in our nature. Why? Because of according to law of conservation of energy, energy can neither be created nor be destroyed. That is the reason. That's why those light energies, mechanical energies, heat energies are derived or converted from the electrical energy. Why we can only convert it from electrical energy means there are a lot of advantages we can derive the energy from by converting the electrical energy. What are those? Means it is very convenient to convert electrical energy into any other forms like light energy, heat energy, thermal energy, mechanical energy, whatever it may be. It is very convenient to convert electrical energy into some other forms of energy. At the same time, the controlling is also very easy. For example, if you can take a fan, by using a regulator, the electrical energy, that means electrical power supply, voltage can be controlled. The mechanical energy produced by the fan also can be controlled. That's why it is very easy to control the output form of the energy by controlling the input electrical energy. That's why we can use electrical energy in the distribution system. One more thing is that there is a greater flexibility in the electrical energy. Greater flexibility means easily transport the electrical energy with the help of transmission system by overhead line conductors. Remaining energies are not convenient to transmit from one place to another place. It is not economical, it is not also efficient. But in the electrical energy form only, there is a greater flexibility to transmit electric power. And it is very cheap to convert. That's why it is widely used, the electrical energy in the distribution system for various types of applications, for various type of consuming purpose. At the same time, cleanliness means here the space occupied by the electrical energy conversion into some other forms of energies are very less. At the same time, the construction is also simple. Finally, high transmission efficiency. Compared to other forms of energy, when the electrical energy can be transmitted to the overhead line conductors, there is a high transmission efficiency. Due to all these advantages, electrical energy can be converted into some other forms of energy and then utilized for cooking purpose, heating purpose, lift the water from the well. At the same time, mechanical energy taken from the fan. That's why electrical energy is superior to the all other forms of energy. That is the importance of electrical energy and why we can generate electrical energy to convert this electrical energy into different forms of energies in the distribution system for the utilization purpose. We can generate and we can transmit. Why we can only generate electrical energy? Why we can not directly utilize those energies means energy can neither be created nor be destroyed. It can be converted. Any required energy can be converted from the some other forms of energies. That's why in this way, that is some other form of energy is electrical energy, because of when the energy can be derived from electrical energy, the conversion is simple. The controlling of that output energy is simple. The transportation of electrical energy for the conversion in the distribution system is simple. So for all these reasons, electrical energy can only be distributed in the distribution system for various types of consumers. That's why we can generate electrical energy. That is the importance of electrical energy. So then now, the very important thing and very important concept, the required concept is, first, in order to convert that electrical energy, how can we generate that electrical energy? Means here also, we can never create electrical energy. It can also converted from some other forms of energy. That's why here, electrical energy can be converted from the energy sources which are available in the nature. So what are the energy sources which are available in the nature? So those energy sources can be converted into electrical energy. That is called generation of electrical energy. Let me see here. What is meant by generation of electrical energy? The conversion of energy available in different forms in nature into electrical energy is known as generation of electrical energy. Simply, the conversion of some other forms of energies into electrical energy is called generation of electrical energy. Those energy sources are directly available in the nature. Those directly available energy sources in the nature can be converted into electrical energy. This conversion is called generation of electrical energy. So what type of energy sources are available directly in nature, and what type of energy sources are used to convert electrical energy, and what energy sources we are used to generate electrical energy means basically in our nature energy sources are two types. Those are renewable energy sources and non-renewable energy sources. The renewable energy sources are also called as non-conventional energy sources, and the non-renewable energy sources are also called as conventional energy sources. Then what are these renewable energy sources and non-renewable energy sources? We can discuss clearly here. So see here, renewable energy sources. What are renewable energy sources? Here, renewable energy sources. Renewable energy sources means always they are new. If we can use these energy sources repeatedly again and again, they are again new. That's why these are called renewable energy sources. That means These are not, these are inexhaustible sources. These are inexhaustible sources. If we are using these type of energy sources repeatedly, again they are reproduced from the nature. That's why these are called renewable energy sources or non-conventional energy sources. That's why these are defined as renewable energy sources or the energy sources which are directly comes from a source and they never runs out. They are again reproduced from the nature. That's why these are called renewable energy sources. What are renewable energy sources means? The solar energy, the light energy are delivered from the sun, that is the solar energy, the wind energy, the tidal or ocean energy, geothermal energy, biogas and biomass are the examples for the renewable energy sources. These sources are repeated if we are used again and again from the nature. These are inexhaustible sources. That's why these sources are called renewable energy sources. And what are non-renewable energy sources? These are also called as conventional energy sources. What are conventional energy sources? Conventional energy sources means if we are using these sources, these energy sources repeatedly, they are not reproduced again from the nature. They are always depleted. They are always exhausted. That's why these are called conventional energy sources. How these are different from non-conventional energy sources or renewable energy sources means these are not repeated. If we are using repeatedly again and again from the nature, these are exhaustible sources. That's why conventional energy sources are the energy sources which are comes from sources that eventually deplete. They are not reproducible. They are always depletable. That's why we are not given any sources. That means any sources like coal, oil, natural gases. We are not given to the future generation. We are using repeatedly. But renewable energy sources are given to the future generations from the nature. But these conventional energy sources are not available for the future generations if we are using repeatedly. So what are the examples of these conventional energy sources means coal, oil and natural gases, water. Nowadays, water is a 100% conventional energy source because of the tendency of rainfall, the percentage of rainfall eventually depleted. That's why water is a conventional energy source. After nuclear energy, etc. are the examples for conventional energy sources. So here, depending upon these conventional and non-conventional energy sources, we can generate electrical energy. Basically, the electrical energy can be generated from the conventional energy sources like coal, oil and natural gases. Means we are burning these fossil fuels. By burning, we are taking the heat energy. That heat energy is given to the water. The water can convert that heat energy into steam. That steam can be converted into mechanical energy with the help of turbines, steam turbines. And after that mechanical energy can be converted into electrical energy with the help of synchronous generators. We are already discussed in the structure of power system. That is the actual energy conversion procedure in conventional energy sources. That means we are heating those conventional energy sources like coal, oil, natural gases, water, nuclear energy. But in case of water, the potential energy of the water can be used to produce electrical energy. That means the potential energy of water can be converted into kinetic energy of water, and after that kinetic energy of water can be converted into mechanical energy with the help of turbines, water turbines. After that, mechanical energy can be converted into electrical energy with the help of generators. In case of coal and natural gases, we are converting the electrical energy by burning of them. But in case of water, by flowing of the water through the penstocks from the pressure head of water in dams. But in case of renewable energy sources, directly the sunlight can be converted into electrical energy, and after the wind energy can be converted into mechanical energy. In case of wind energy, after that mechanical energy can be converted into electrical energy. In case of tidal also, the tide's kinetic energy of a ocean can be converted into mechanical energy with the help of turbines, and after that mechanical energy can be converted into electrical energy with the help of generators. So that means whatever the generation we are considering except solar energy, they requires turbine to generate mechanical energy. After generator, that means turbines and the generators are the missions which are required, to produce electrical energy. So all these power generation techniques, all these energy conversion techniques are clearly discussed in our first and second units. In next class, we will discuss the generation of electrical energy in thermal power stations. Thank you.